Hi everyone, and welcome to Erik's Electronics Workbench. So it's repair time again, and today I have this NAD model C356BEE stereo integrated amplifier. So let's get started, see what's wrong with the amplifier, and what it takes to put it back into service. So the information that I have about this NAD amplifier is that it has no output and that it seems to go into a protection mode when it's turned on. So we need to verify that that's the fault condition and then proceed with the troubleshooting. So I'll take the top cover off before I power it up, just take a look around inside the amplifier, make sure that visually it looks okay, you know, there's no overheated components or a leaking capacitor or something like that. Anything like that would need to be addressed first before we power it up. Now this is known as a stereo integrated amplifier, just meaning that it's both a preamp and a power amplifier in one chassis, as opposed to just a power amplifier where you'd have a separate preamp. And a stereo receiver, of course, contains a tuner, where this does not have a tuner in it. So just looking at the front panel quickly, there's a power on-off, which actually is a standby switch. There's also a power switch on the back panel. It's a hard power switch. This is controlling the microprocessor inside. There's a phones output right here for headphones, speakers A and B. MP jack right here is a media player. It's just a convenience for a front panel input connection. And then of course there's a whole bunch of connections on the back panel as well. So selections right here for the various inputs, auxiliary, tape, tuner, so forth. Bass, treble, and balance control, and of course volume control. So very typical type controls that you'd find on an amplifier. There's also right here it says soft clipping. That's a little indicator light if the soft clipping mode is enabled. And I don't know if it comes up on the camera, but right here there's a little window for the infrared remote. I don't have the remote for this, but the remote control doesn't have anything extra that you can't operate, right on the front panel. So really nothing missing. It's just convenience. The remote can run the volume because it's a motorized volume control, and it can select these various inputs and turn the power on and off. So turn this around here and take a quick look at the back panel here. So a whole selection right here of the RCA jacks for the various inputs. RS-232 input for some type of remote control. There's a 12-volt trigger out right here for controlling other equipment. Infrared in and out. So let's say that this is stored away in an equipment cabinet or something like that, where the window for the infrared remote on the front wasn't visible. You can have a repeater and just basically connect the repeater here and send the signal in. So it's a nice convenience. Links right here that jump the pre-out to the main in, so you can break these links and the preamplifier's output signal can be run into an external processor, equalizer, something like that, and then that can be run back into the main input, or you could actually have a separate preamplifier and then run that into the power amp, so it gives some more options there. Of course, the main outputs for the speakers A and B. That soft clipping control that I mentioned, there's a switch that's hidden down under here that you can move to turn that feature on and off. The line cord plugs in here. You'll notice this cord does not have a ground connection. They float the chassis. That's commonly done on audio equipment to prevent ground loops. So this is just a 2-wire cord. And then this is a power switch right here. So when this switch is off, it completely shuts everything off. And when this is on, basically the unit just goes into standby. And then right here, there's actually a module that was an option, and this is populated, which is really nice. So this is the DAC module, so digital to analog converter. This has a USB input, an optical input, and it also has a switch here that says phono, and I'm not sure for the phono if this has a phono preamp in this module as well. I'm a little bit unclear about that. I'll have to look in the instruction manual. I haven't read up on that yet. And if so, it converts, I think, one of these inputs to a phono input. I think the disc input gets used instead. So I'll have to look at that a little bit closer and see what's going on. But it is nice to have this because the USB input and the optical input, you have a digital audio input directly into this. So that's a nice feature. There were other modules that could be used as well in here that the NAD produced. And I think one of them was a dedicated phono type preamp as well. So let me get the top cover taken off here and let's take a look inside. So I'll just turn this around here and just a couple screws here, each side and on the back. All right, and we're in. Looks really nice inside there. Pretty clean condition. So just at the first glance, let me move the camera to a little bit better position and we'll take a look inside. So on the first glance, the amplifier looks very nice on the inside. It's extremely clean, and I don't see any evidence of other repairs that had been done. And I'm not seeing any components that look overheated or damaged, so I think it's perfectly fine to go ahead and power it up and verify the problem. Now to power this up, I'm going to use my current limited isolation transformer and variac, but I'm not going to bring up the line voltage slowly, so I'll just put the full line to the amplifier, we'll turn it on and see what happens. But it will be current limited by an incandescent lamp that's in series with the line, so if there's something drastically wrong, it draws excessive current, that lamp will just glow very brightly and I can shut things down. It prevents other types of damage from happening, so it's a very safe way to power up the amplifier. But again, I'm not going to bring up the line slowly. Now, you may have heard about old vacuum tube type equipment, about bringing up the lines slowly, letting capacitors reform, things like that. And that's perfectly fine to do on vacuum tube based equipment, but on solid state equipment like this amplifier, I definitely wouldn't recommend bringing up the lines slowly. It can lead to other problems. Oftentimes the circuits in solid state equipment just don't play nicely with low line voltages. Again, it can lead to other problems, so I wouldn't recommend doing that. But again, doing that current limiting is a good idea. So just taking a quick look at the general layout inside the amplifier, you can see the large toroid type transformer over here in the corner. Power supply right here, so large filter capacitors, NAD branded. Two heat sinks here. I can see some bridge rectifiers on them and some other devices on the back, maybe transistors or voltage regulators. I'm not really sure. Have to take a closer look at the schematic, but I'm seeing a very small transformer right here with that little yellow band across the top, and that tells me there's probably a switching type power supply in here as well. That transformer is being switched at a very high frequency, but it's very small, so maybe a standby type supply, or just an internal power supply to run some of the auxiliary circuits. Some filtering right here on the AC line coming in. It's typical of what you'd see in a switch mode type power supply as well. A number of other electrolytics around here, so all the main filtering and everything going on over here. So the main heatsink right here, so the output devices are bolted to this heatsink. There's a slot in the bottom of the chassis, and then of course the vent in the top, so the air is just convection cooled, just coming through here. Some more heat sinks right here. So you can see the two channels of the main amplifier in this area. So there's a bus bar right down the middle, and very symmetric on each side. So these heat sinks right here probably contain the driver transistors, the VA stage. The VA stage, or voltage amplifier stage, in an amplifier like this often runs in class A, so it dissipates a fair amount of power. So it's not unusual to see another heat sink just for the VA stage. So really nice layout, very clean design, and really nice quality. You can see these large copper, basically like bus bars that come up here to the speaker output terminals. So again, really nice quality. Speaker relays right here for the A and B switching, some filtering known as a Zobel network on the outputs right there. Tone control board over here for bass and treble volume. There's a motorized volume control there. Some more heat sinks here with some devices on them. I'm not sure exactly what's going on. Probably power supply section, I would imagine. Maybe some voltage regulation going on back there. Here's that DAC module, the power supply right here for that module, and interface connection right there. So there's a number of relays right here, and they're kind of hidden underneath, but those are the input selection relays. Some cables that run around this corner and up to the front. So this front panel has some more, another circuit board, more components in here, and I believe there's a microprocessor on that front panel. It's kind of in charge of controlling all of the functions within the amplifier. Now this amplifier is all discrete components, so as you look through the audio chain moving through here, everything is discrete components, individual transistors. There are no amplifier chips or op amps and things like that that are in the audio chain. There are a couple op amps I'm seeing down on the board right here and over here, but they're not part of the audio circuit. All right, let me grab my power cord, get this plugged into the isolation transformer and variac, and we'll see what happens. All right, the isolation transformer and the variac are both turned on, and I have the incandescent lamp switched into the circuit for the current limiting. So I'm using a 150 watt incandescent lamp, by the way, so that should be perfectly fine for this test. So I'll reach around back here, turn this switch on, and I'll keep an eye on the meters on the variac for any excessive current draw or power consumption. Here we go. That looks okay. So the watt meter barely bumped up. It came back down. So it's in the standby mode, and yes, it is. The little amber light is turned on. So that's normal, no problems there. So in the standby mode, it draws just a very small amount of power. So now I'll go ahead and turn this on. Let's see what happens. Oh yeah, there's a big surge right there. Let's come back down. Okay, here I click. And I'm seeing some indicator lights here. So this turned to blue, so that's normal. Speaker A. Soft clipping light is on. It looks like the CD has been selected. Yes, it does select other settings. Okay, so it's responding to the button presses, and the indicator lights are changing, so that's a good sign. I don't see any problem. This is blue, and if this goes into protection mode, this will turn red. So no problem so far. Now the incandescent lamp is glowing, but not excessive. And the watt meter is showing about 50 watts, maybe just a little bit over 50 watts. So yeah, I mean, that seems about right. It is going to dissipate some power all the time because of the idle current. So I'm going to go ahead and switch off the incandescent lamp so it'll just go straight through now, because there is some voltage drop on this incandescent lamp. So it's out of the circuit now. And it went up to 60 watts. That seems a little bit high for the power consumption. I'm not sure that it should be quite that high. The idle current might be a little bit high, but it's sitting there. Oh, did you see that? It just went to the protection mode. That turned red. Oh, and I'm noticing something else too. The watt meter is fluctuating. It's going up and down. Actually, I don't like that at all. It's going up to almost 70 watts. And then now it went down to 50. Kind of hunting all over the place. Yeah, that doesn't look right. I'm going to turn this back off here. Yep, it just went down to 0 now. So the power consumption is not stable at all. Definitely hunting around, and then again this went into the protection mode. So it does look like there's a fault. You know, sometimes the protection mode, if there's a fault in the protection circuit, it could go into the protection mode when it shouldn't. Let's say it's detecting an over temperature condition when that's not really happening. In this case, I think there really is a fault, and maybe a DC offset or something like that's going on, and it's detecting that, and then you know, it's tripping the protection and shutting off the speakers. So definitely going to have to just start doing some troubleshooting and see what's going on. Let me move the camera over to the watt meter on the Variac, and you can see the fluctuation that's going on. So I'll just reposition things here and you can take a look at that. All right, here we are looking at the meters on the Variac. So you can see on the AC amps, it's set to 5 amps full scale. So 1 amp would end up blowing the fuse with the inrush current, so that's why it's on 5 amps. AC volts is set to 120 volts output. And then the watt meter is set to 150 watts full scale. So I have the incandescent lamp switched into the circuit for the current limiting. And I'll switch on the power amplifier into the standby mode right there. So just a slight deflection on the watt meter. It's almost nothing at all though. Very, very minimal power consumption in the standby. All right, now I'll go ahead and turn on the amplifier. All right, so big current surge right there. Big power draw at first, but that's normal. It's the inrush current. The capacitors charge up. So the incandescent lamp is just glowing slightly, no problems there. And the watt meter is very steady. I don't see any fluctuations or movement. And it's not in the protection mode. The blue light is on, so that's normal. Switch this over to 1 amp. You can see it's just about a ½ amp of current draw. And 5 amps, you know, the reading is way over here on the end of the scale. All right, now I'm going to go ahead and turn off that incandescent lamp, or bypass it. So it's out of the circuit, and the full line voltage is applied to the power amplifier, because a little bit of voltage does drop on the incandescent lamp, you know, because it is glowing slightly. So it's out of the circuit now. You can see the watt meter jumped up a little bit higher. So it's about 60 watts of dissipation again, as we saw before. Seems a little bit high. I don't think it's supposed to be that high at idle. So it's not in protection mode at the moment. Still sitting there okay. Up there it goes. So it's in the protection mode. Red light is on, and look at that watt meter. See, it's there it goes. See, it's moving around. That doesn't look normal. That shouldn't be moving like that. Now it is normal to have a slight fluctuation as the idle current fluctuates a little bit with temperature, but not that much movement. That seems to be too much. So I'm going to go ahead and turn that back off again. And it just falls to 0. So that, again, that seems to be a problem there. We need to take a closer look and see why is what appears to be too much power consumption just at idle, and why is it fluctuating like that? And of course the protection mode. So some clues about what's going on here. Let's start some troubleshooting and start taking some measurements on the circuit board. So the next thing to check for is to see why the amplifier is going into the protection mode. So normally amplifiers that have protection circuits will monitor for overtemperature, overcurrent, and DC offset voltage. Now, left unchecked, the DC offset voltage can lead to overtemperature and overcurrent conditions, but when you have a protection circuit, it's going to catch whichever fault occurs first. So if it's a DC offset, then it just disables the output and it prevents those other types of situations from occurring. Now, I noticed that this heat sink where the output devices are mounted has a temperature sensor in this corner and one over in this corner. And this heat sink is barely getting warm, so I don't think it's an over temperature fault. If it is, then there's something wrong with the temperature sensors, but again, I don't think that's the issue. And I don't think it's an overcurrent condition because nothing's connected to the output, and I don't see any components here that look overheated or damaged in any way that would be causing a short circuit. So that leaves a DC offset voltage as the most likely issue that's going on. So we'll check for that first. And it's very easy to measure. We just have to measure across the output of the amplifier in each channel. Now I noticed right here on the circuit board, there is a left channel and a right channel test points, and they're right before these relays. Now when the protection circuit kicks in, these relays turn off. Everything else remains active in the amplifier, but you can't measure the DC offset on the output at the speaker terminals, because once the fault occurs, these relays turn off, and then you would never measure anything out here anyways. So these convenience test points right there on the board and right there are perfect to measure at. Now, these test points, there's a pair for each channel. I already measured with the ohm meter, and one of each test point goes to chassis ground, which is also where the negative terminal for the speakers ties. So that's just a convenient point right there, so I can measure across each of those pairs. So I'll go ahead and turn on the amplifier, and let's take a measurement and see exactly what happens. So it's turned on. Reach over here. Okay, so the amplifier is powered up, and it is not in the protection mode yet. So wait just a little bit. Let me grab my test leads here. So the digital multimeter is jumping around on its display just because these are floating. If I touch those together, you can see it falls to a very low value. So the amplifier still looks okay. It's not in protection yet. Go ahead and measure across here just to get started. So typically the DC offset voltage should be a very low value down in the millivolt range, ideally very close to 0. So that's the right channel, and it's sitting at about 3 millivolts, so that's not a problem. Let's look at the left channel. And the DC offset could be positive or negative. The left channel looks like that's hunting around considerably more. Also some higher values. So it's still not in the protection mode. No, it looks okay still. So I'll just let things sit here a little bit until the protection mode kicks in. It seems to do that pretty reliably within a short time of powering things up. Okay, the protection mode just kicked in, so the front panel indicator light is red. Let's take a look here and see. Go back to the right channel. There. Still sitting at 3 millivolts rather, very low. The left channel here, let's see what we have. Definitely higher values on the left channel. I mean, that's basically 100 millivolts at times right there. It looks like there was a higher voltage spike there. I don't know if the meter caught it, but I could hear the range switch a little bit. Like it jumped up there. Oh yeah, that jumped way up. That was, what, 30 or 40 volts? Okay, so I think, yeah, there's something going on in the left channel. There was a big voltage spike there. You know, I'm smelling something kind of warm in the circuit too, and quite a bit of warmth over here in the circuit. This heatsink is barely warm, which is a good sign. So I don't think there's, like the idle current doesn't seem to be excessive. Over temperature faults can occur if the idle current is far too high. But I don't think that's the issue here because this is not running excessively hot. But this power supply section over here, really a lot of heat coming up over here. It seems a little bit much. Let me grab my thermal camera real quick here. Take a look at that. Okay, here's the thermal camera. Let's take a look at the circuit board here. See some components over there that fairly warm. I'm seeing some of those components there are running at 245 degrees, so that looks really hot over in that area. See, 277, 290. Whoa, not sure exactly what's going on over there. I have to see which component that was. And the power supply section, 213 right there. Oh, there's a glare. Sorry, you can't see the screen there. So 180, 240. Whoa, that's really hot. So the center dot is not accurate when I'm real close like this. I have to go down a little bit to offset on the screen to get the temperature reading. But this area right in there in the power supply, you can see how the color shows that it's much hotter over there. So very hot in that area. And then, so this area and this area definitely have some components running quite hot. I'm going to turn this off. I don't like how hot that's getting. So there's something going on because, yeah, there's a lot of heat coming up from this power supply. Remember, the power consumption of the amplifier seemed like it was on the high side as well. And that would explain, you know, that there's maybe a excessive current flow, you know, through a device or something in here. So let me do some more troubleshooting here and take a closer look at the schematic and see exactly what I can find out. So just the usual reminder that if you're following along and working on an amplifier like this, you're definitely doing so at your own risk. Take care and be safe. Remember, there's elevated voltages within this power amplifier. There's plus minus 55 volt rails. If you come in contact with 55 volts, you'll definitely get a shock, and you don't want to mess around with 110 volts. If you come across, you know, the positive to the negative rail, it's 110 volts. That's not something to mess around with. So take care and be safe. And also, of course, it's an AC line operated device, so you need to be cautious of that AC line voltage coming in as well. But there's you know, 110 volts basically around this entire circuit board in many places between the two power supply rails. So again, if you're following along, you're doing so at your own risk. All right, the next thing that's a good idea to check are the power supply voltages. So I'll turn the amplifier back on. There it goes, it's powering up. And actually it already went into the protection mode. It seems to do that rather quickly sometimes. So grab my test probes here. So let's take a look at some of these rail voltages. So it looks like there's a ground point right here on the board, so I can use this as a ground reference. And they did a nice job marking the board with voltages here. So right here's a minus 26. That looks good. Positive 26. That looks good. Negative 18. Looks good. Actually a little bit high, but probably okay. Here's positive 18. Slightly low, but pretty close. Down a little bit though. I think that should be closer to 18 volts, but keep that in mind that that one's reading a little bit on the low side. Here's positive 55, one of the main supply rails. 53. So that would fluctuate a little bit with line voltage variations as well, but also negative 53 on the negative 55 rail. So they're basically equal in value, but down just a little bit from the 55, but I don't think that's a problem. My variac might be down just a little bit on its voltage, pretty close to 120, but that's probably okay. Let's see here. I think over here, there's a 12 volt that I saw. Well, here's 5 volts, so let's look at this. Yep, 5.2, no problems there. And yes, there's a 12 volt right here. Yeah, that looks okay. So none of the supply voltages really stands out except for the one 18 volt rail that looks like it's maybe down just a little bit, but it's interesting, one of the 18 volt rails seems a little high, one seems a little bit low, so something to keep in mind, but continue on with the troubleshooting and see what I can figure out. So I started taking some measurements with the oscilloscope, and what I found is that everywhere along the audio path of the left channel power amplifier section, it's extremely noisy. There's all kinds of voltage spikes and pulses that are occurring. They're very random in nature, and some are extremely high in amplitude. So I think that's when the protection circuit is tripping. Now by comparison, the right channel is very quiet. I don't see any issues going on over there. So I think we can rule out the power supply sections because the 18 volt, the 26 volt, and the 55 volt rails are all common to both channels. So if the right channel can cooperate and work correctly, then, again, I think the power supplies are perfectly fine. Now that one 18-volt rail is down just a little bit, and some of the components in the power supply section over here are running very hot. At least they seem, excessively hot to me. So I'm wondering if the left channel's problem is also, pulling down and loading this power supply excessively. So we'll find that out as we continue on with the troubleshooting. So we'll take a look at the oscilloscope in just a second, and you can see the noise pulses that are occurring in this circuit. But looking at the components over here, this connection right here in this little cable and plug, this is coming from the preamp section, and then of course this is the power amp section. So I unplugged this and it didn't change the problem. So the noise source and problem is not coming from the preamp. Now, the signal comes from here and it goes onto this board. This is all surface mount components on here. So this is just the initial input stage. And it comes off of this board, passes through these components, makes its way over here to these power devices, ultimately to the output transistors right here, and then of course off to the speakers. So let's take a quick look at the schematic here. Touched up here so you can see this. So if we take a look at the schematic, this is just the left channel. I just enlarged it so we could see it a little bit easier. Put that up just a little bit there, okay. So here's the audio input on the rear panel, the RCA connector. Here's that plug that's on the circuit board. So the audio is coming in here. It's coming through some passives right here. This is the connection that this module is attached to the main circuit board with. It's not a plug that plugs together. It's actually soldered onto the board. The audio signal comes in here to this initial input stage right here, makes its way over to this second stage right here. It's coming down here through some more passives, comes back around, leaves that board, comes all the way over here, comes up. We have two diodes right here. So the cathode of this diode and then the anode of this diode are joined together right here. So the audio path comes in right here and it makes its way over to this next stage and ultimately over to the output stage, and it's off to the speakers. But on this area right here, there's two transistors and they have the collectors tied together. And I'm going to take a measurement right at that point because it's very easy to get to. It's right on the top of this board. The two transistors are right here. Let me touch this back up again so you can see that. So those two transistors are right here. The collectors tie together, and there's what looks like a large ground plane up here, but it's really acting like a heat sink on the top of this board. So it's very easy to probe right there. And I'll take that measurement, and you'll see the noise that's at that point. Now, you have to remember that in the design of this power amplifier, like all modern power amplifiers, there's a feedback. So it's a negative feedback, and it's a very common technique that's used. So because of that negative feedback, the noise that you have in the circuit, maybe the noise is originating in the input, but it makes its way through the entire stage, but it comes into that feedback and comes back around again. So everywhere in the path, you're finding that signal and that noise, no matter where you measure. So maybe, let's say one of these transistors over here is the source of the noise. Well, the noise still occurs, in the input stage because that feedback is coming back around again. So it's basically kind of like a loop, but it's negative feedback as opposed to positive feedback. So you're not getting, an oscillator because oscillator is positive feedback. So in this case, it's negative feedback, but the noise is everywhere, and I just can't really, narrow it down. I also used a noise probe, which I've used previously in testing and repairing another amplifier. I was able to detect a noisy transistor that way. I tried it, and everything is just too close in here, and I'm not able to really pinpoint any specific component. Everything is almost, equal in amplitude in the noise that I'm hearing throughout all of this area here. So unfortunately, that didn't narrow it down. It did seem a little bit stronger, I would say, near this board, but I can't say 100% because I was certainly hearing it over by some components over in this area as well. So let me move you up to the oscilloscope, and again, I'm going to just probe right here and take a look, and you can see the noise pulses that are occurring here. So let me just get this moved over here, pardon the camera movement. All right, so I'm going to take the oscilloscope probe and just touch the collectors that I just mentioned. Okay, right there. And take a look at that. That looks terrible. There's a lot of noise there. It's extremely random. So that's 1 volt per division on the oscilloscope. You can see some of those are considerably larger in value. It's really not just one pulse. I mean, it's just random, very rapid, fast pulses together. But some of those Like right there, that almost looks like an oscillation. But then it goes away and it's just completely random. So I'm looking here and the protection mode is not tripped. So if you had a speaker connected, it would be crackling and static and all kinds of noise, but I don't know, the output would be pretty substantial, I would imagine. Let me go over here to the left channel, see what the actual amplitude would be coming out here. So that's the left channel output. I think I've got it on there, right at the speakers. So that's 2 volts per division. So again, that's right at the speaker connection. Make sure if I go over here, yeah, that's ground, so I'm on the correct test point right there. Now if I go over to the right channel, right here, make sure, let's see if it's this one right here. Yeah, both look basically just dead quiet. So the right channel doesn't have any noise whatsoever. No issues going on there. So let me move you back down to the amplifier again and take a look at the circuit board. So I think the next step for troubleshooting is to remove this module. So by removing that module, it's going to break the feedback loop that occurs within the power amp section. And I think that'll make troubleshooting easier. Also, with this removed, I'll be able to test just this module and see if the noise is present anywhere in the circuit on this module. And if it's not, then obviously we'll test the rest of the circuit here. It has to be somewhere, but by breaking this and removing it, and just take advantage of the fact that we can remove this module because it's not part of the main board. If these components were all in the main board, obviously, it'd be much more difficult. So just kind of use it to our advantage that this is a separate piece here. Now, I have to power that board, and it requires plus minus 18 volts and the plus minus 55 volts, and the plus minus 55 volt rails go through some dropping resistors. So I think to power this board, instead of using a bench type power supply, I'll just power it off of these power supplies. I can run 4 wires from the main board over to this little board, and just have it outside away from the amplifier. So by doing that, I can also monitor the current draw on this board, and we'll see if it looks excessive or not. And also, it'll be interesting with this board completely disconnected. Does it change the power dissipation that we're seeing in this power supply section? Does it start to run cooler? What effect does that have? So I think by removing this board, it'll accomplish a number of things for the troubleshooting. So I'll continue with all of that. I also want to look at the schematic. Make sure that removing this board doesn't cause any other problems. I don't think it will. I think it'll be perfectly fine to take it out. It'll break that feedback loop, but there just won't be any audio signal passing through. I don't think it'll upset the bias and some other things that are going on in the circuit. The audio path does have a 47 k ohm resistor to ground coming off of this module, so I may want to install that resistor just for safety. I may want to have that in the circuit, but I'm going to take a closer look at all of that. So I'll continue with the troubleshooting, and I'll show you what I find out when I get that removed. So on the bottom of the amplifier, this entire panel is removable, so it's very convenient. It gives access to the circuit board for servicing. So I have my trusty Hakko FR301 desoldering tool, so I'll use this to desolder these pins on that little circuit board right here. All right, so the module is removed. So I thought I'd start by powering up the amplifier with the module out of the circuit and see what effect that might have. Well, all of the noise has disappeared from the amplifier's output on the left channel. So it looks to me like that module is where the source of the problem is. We'll need to do some more troubleshooting on that module and see what has gone wrong with it. So right now the amplifier is powered up, and you can see right down here the oscilloscope is connected to the output on the left channel. So I'll move you up to the oscilloscope and you can see how noise-free the output is now. Now something to make note of is that on this module right here, you can see the little pins across the bottom. So they actually start counting on pin 3, so it goes 3 through 10. And I soldered a 47 k ohm resistor between positions 5 and 8. Position 8 is ground, 5 is the audio output from this module. So that resistor is soldered on the other side of this board. But there's a 47 k ohm resistor on this module, and in looking at the schematic, I thought it would be a good idea to keep that resistance in the circuit. So, that was the only thing that I've done so far. So let me move you up to the oscilloscope here. Pardon the camera movement. So you can see how noise-free the output looks. So this is set to 50 millivolts per division. It's a DC coupled, and it's down 2 divisions. So basically 100 millivolts of offset right now, but again, very, very noise-free. So I'm very happy how that looks. And there's a servo circuit in this amplifier that helps to correct for any DC offsets. And that's out of the circuit now with this module breaking the feedback loop. So this offset right now is basically occurring in the output stage, but that servo circuit, there's an op amp that's part of that, would be able to correct for that. So that doesn't look to be any issue at all. So let's take a closer look at the module and get that powered up outside of the amplifier and then start taking some measurements on the module. So I was taking some measurements around the circuit board, and all of a sudden I noticed something that didn't seem to be correct. So let me show you what's going on. Now keep in mind that I've not actually tried to put audio through this amplifier yet. I haven't connected any speakers to it. I've not put any audio signal into it. And after taking these measurements, I believe the right channel also has a problem. So the digital multimeter is in the resistance mode. So if I take the one test probe and just touch it to chassis ground, back here is the RCA connectors on the back panel. So this is the power amp input. If I touch this metal area right here, that's the left channel that I've been working on. So you can see the resistance reading for the left channel amplifier input is it's increasing. There's some capacitance in that circuit. But you can see that's about 219 k ohms, 220 k ohms right there, and it levels off about 220 k ohms. Or as the digital multimeter is showing, 0.22 megohms. So I believe that reading is correct based on the schematic and the resistance values that I'm seeing. Now, if I go over to the right channel input, which is this little metal area just below that right here, look at that reading. That's only 471 ohms, or 0.471 k ohms. That's a drastic difference between the two channels. There's no way that that can be correct. I mean, that's many, many times difference in the resistance between the inputs on the power amplifier section. So when I saw those readings and how much they, differed between them, I thought, nah, I need to take a look at that. Now, the module that I removed is still sitting right here. Haven't even gotten to that yet. And I don't know, I'm suspicious of that module based on the other tests that I've already shown you, but this is, again, looks like it's affecting the right channel. And so I think we've got two different problems going on here. And the problem on the right channel seems to be a little bit unusual as to maybe how it happened. So the next thing here is, I'm going to turn this around right here. So I think that, actually I'm going to turn it all the way over like so. Yeah. So I'm going to put a photo up on the video, and you can see a close-up of the circuit board. And what you're going to see in the first image is the test probe is pointing to a little soldered bridge that's joining two traces together. And then in the second photo that I put up, you'll see that I've removed it. All I did is I touched the tip of the soldering iron to it, and it just melted it away. And I confirmed that there was continuity with that solder bridge between two different circuit paths on the circuit board, two different traces. Well, that's obviously a problem, and how did that get there? Did that leave the factory there, with that little solder bridge? If it did, this amplifier never worked correctly, or has someone been in here and was, working on it and splashed that solder on there, or, accidentally did that? I really don't know. It's hard to say. Unfortunately, it looks like that solder bridge has damaged some components because it basically caused a short circuit. So if we take a look on the other side of the board right here, it's I know you can't really see it on the camera right now. It's a little bit difficult because the parts are so small. But right here on the circuit board, there's a resistor right here that says R11. Okay, and again, this is on the right channel, so this is completely unrelated to that module or anything that was going on the left channel that we were looking at already. So a little bit sidetracked here on the second problem. But again, if I go to chassis ground and I go to this resistor, you can see on one side of it, right there, there's that 471 ohms that we were seeing before. If I go to the other side of that resistor, about 4.5 ohms to ground. Well, that's a big problem. Basically, what that means is that the right channel would not have passed any audio. All the audio would be shorted to ground. Now, the question is, where is that short circuit? So this R11 resistor right there, let me show you on the schematic over here. I'm going to grab this. Fortunately, this printout is rather small. I'm going to set this here. I'm going to reposition the camera a little bit here and get this zoomed in. And we'll take a look at this, and I'll show you where that resistor is at and what I think has happened. So let's take a look at the schematic for the right channel. So we already saw the left channel section down here. I had enlarged that earlier in the video, but this is the complete power amp circuit with both the left and right channels. So the right channel is up here in the top. And I know this is printed really small in here, but basically this is the input for the right channel, and here's R11 right here, okay, on the schematic. So basically the signal is coming in here, it goes through this plug on the circuit board, comes down, it comes over to R11, and R11 is a 470 ohm resistor. So on one side of R11, you should see a resistance through a 220 k ohm resistor to ground, and we do see that on the left channel. On the other side of this R11, you come through that, you come over here to these two transistors, there's an NPN and a PNP transistor, and this is part of the soft clipping control, this whole area right here. And so the other side of these transistors, their collectors are tied to ground. Well, we're getting almost a direct short to ground from this side of the resistor, to ground, and the only way it could do that is through these transistors, either one or both of them. And then if we continue on, there's two capacitors that are in parallel. They're just two different values, but they've paralleled them. The other side of that goes into this resistor, and this side right here also pulls down to ground. Let's see, this is it looks like a 22 k ohm resistor right here, and then this continues on, and then here's the module for the right channel. So I believe that these transistors, one or both, are defective in this clipping control circuit. So by comparison, on the left channel, I'm not seeing any kind of short circuits or problems like that. So this is completely unrelated to the other problem, but the right channel certainly wouldn't have worked the way it is. So I'm going to desolder these two transistors and just test them out of circuit, because I can't tell, if one or both is defective the way it is right now. So I'll remove those and let's take a look at those transistors. If that's the only problem in the circuit, that'll be an easy fix. And in fact, I think I can just test it with those removed, because taking those out will just basically disable the clipping control circuit on the right channel. So not a big deal there. Now, because that's a short circuit right there, I do need to take a look at some of the other components down here. There's a Zener diode for the positive and negative rails. I'll check those components as well, just to make sure that there's no other damage going on in the circuit, because that solder bridge was in this area of these components. So I think that's why these have been damaged. All right, so I'm going to continue on. I'll desolder those, and let's take a look at those two transistors. All right, so I've removed the transistors and the Zener diodes from the clipping control circuit. So these two transistors were on the left channel, these two are on the right channel, and the Zener diodes are for the power supply rails in that clipping control circuit, so that's common to both channels, and there's a positive rail and a negative rail. Now what I found is that after I removed the transistors on the right channel, that short to ground that was measuring about 4 ohms or so, that disappeared. So the right channel is looking very good now with those transistors removed. Definitely a problem going on here, and I'll show you what I found in just a second. Now, I removed the transistors, but I had initially left the Zeners in circuit, and I powered up the amplifier, took a voltage reading, and what I found is that the Zener diode that was right next to that solder blob, right in that same circuit where that short was across on the circuit board, that Zener has failed. So it wasn't regulating at all. These are supposed to take 55 volts, drop it down to 20 volts. It was just passing 55 volts straight through. Now the other Zener seems to be regulating okay. It was measuring about 22 volts, but obviously both will get replaced. Now when you have a Zener that's no longer regulating, or any circuit where the voltage is not regulated properly and it rises up too high, other problems can of course occur, because it could damage other components if the voltage is too high. And I think that may have been what happened over here on the left channel, because there's an issue going on over here as well. So I'm starting to think that maybe that module is not the source of the problem. Maybe all of the noise was occurring in these transistors or a noisy Zener or something going on here. I mean, we have a lot of failed components here. So what I'm thinking is leaving these out of the circuit, because that'll just basically disable that clipping control circuit, and put the module back in place and see if the amplifier comes to life and starts working, correctly. And if it does, replace these and we're, back in business. Because there's definitely some issues, going on here and some odd problems. Now, one of the reasons I started looking at this whole circuit is because what I noticed in testing is that there was a DC voltage appearing on the input to the left channel. So if you go to the rear panel, it's RCA connector for the power amp input, I was measuring about 22 to 24 volts on that RCA connector. That's definitely not correct. And so I started investigating why that was happening, and that voltage was occurring with that module removed on the left channel. And what I found is that the only path to a voltage source would be through this clipping control circuit, and that's why I started looking in this area and investigating a little bit closer. And initially I measured, resistances that were incorrect that I already had mentioned, but then, now measuring some of these transistors that had failed starts to explain why that voltage was appearing. So I think that's also going to explain maybe where the noise was coming from. We'll find out and see. That maybe is completely wrong. Maybe there is a problem with that module, but nonetheless, this is definitely a step in the right direction, and a lot of parts here that are defective. The resistors that are in that clipping control circuit look to be fine. I don't see any issues going on with any other damaged components. So let's take a look at these components here. This is in the diode test mode. I also have a transistor tester and a Zener diode tester, and we'll use those as well. So these transistors are facing the flat side down, so when they're positioned like that, it's base, collector, and emitter going across. So when you test a transistor, if you go from the base, these are also NPN and a PNP. I don't know which is which, but that just affects the polarity, but the testing procedure is the same. When you go to test a transistor, if you go from base to collector, you should see a diode junction, and we do, okay? And from base to emitter, a diode junction, and yes, we do. Okay, so no problems there. Then reverse the polarity, and it should be an open. Yes, it is. And yes, it is. No problems there. And then collector to emitter should be an open circuit no matter what. And yes, it is. Yes, it is. No problems there. So let me grab this little transistor tester. So I'm just going to connect this onto here like so. Okay. Okay, there it is. So it says it's an NPN silicon, and it has the readings, and you can scroll through and see a number of other parameters, but basically it does test as a good transistor. So no problems there. I will replace this transistor anyways, but it does test okay. Now, if we take a look at this next transistor right here, same thing. Go like this, so go from the base to the collector. See nothing there. If we go base to emitter, we see nothing there. Reverse the polarity. Base to collector. Okay, there's a diode drop, that's good. And if we go base to emitter, it's still an open. So that transistor has failed. There's a problem there. It has an open junction. If we go from collector to emitter, that's an open. That's an open there. Okay, so now if I take the transistor tester and just clip this little transistor on here. All right, so the result comes back as a diode junction, which obviously is incorrect. It's just measuring that one diode junction that's within the transistor, so it thinks it's just a diode. So that completely has failed, but it hasn't failed to a short. It's basically just not working correctly, but that could easily be a noise source. I mean, that transistor, who knows what it's doing internally. So I'm wondering if that's, again, where some of those voltage spikes and pulses were actually originating from. So now going over to the right channel here, if we take a look at this transistor, again, base to collector. Looks like that's the open there, and base 2 emitter. Oops. So that looks like an open there. I'm not getting any measurement, any reading. These things, they flip over like that, and you can't get the test leads on there. Base 2 emitter there, that looks like an open. And let's just grab this tester here. Let's see what it reports on this one. And it says no component found. No, actually, what does it say? It says red and green leads shorted. Nope, and they are not shorted, so there is a short within the transistor. Okay, so test one more time on that. Yeah, red and green leads shorted. So the red and green, that's actually the one test I think I didn't do here. Yeah, I forgot to do that with the digital multimeter. If we go from the collector to emitter, sure, there's the short circuit right there. That's my mistake, I forgot to measure that. And there it is again. So this transistor is completely shorted, and with that short circuit, that could explain why the power supply was running, excessively hot, because this is just a direct short to ground, and the Zener was, defective, and the whole circuit wasn't working correctly. Let's grab this other transistor right here. So again, go base. This one here, the leads are kind of bent on it here, if I can get in here. That's a diode drop there, that's okay. That's base 2 emitter, that's probably okay. Open there. Collector to emitter. Okay, this one's shorted as well, it looks like, unless my leads were touching. Yeah, this one looks shorted as well. So again, if we just put this on the tester. Okay, run the test here. And it comes back, it says 2 diode junctions, common cathode. Well, obviously that's not correct. Yeah, so it's confused about the component, so clearly the transistor is defective. So it sees some diode drops in there, diode junctions, but there's a short as well. So again, this was on the right channel, and it explains why that right channel's audio line was being pulled to ground. So if this amplifier was actually, if you tried to use it, the right channel would not have passed any audio. It wouldn't have worked correctly at all. So it's really strange that it had that solder blob, or that, did it leave the factory that way? This would never have worked correctly. Or again, was someone in here and accidentally caused that? Not really sure, but that little solder blob certainly damaged a number of components. Let me grab my Zener tester right here and check these right here. So this. Okay, so on this Zener, you can see it says voltage of the Zener 0.71 volts. So that's completely incorrect. So that's failed. And grab this one right here. So this one actually is testing okay, which it did look okay in circuit as well. So it's measuring, it says it's a 19.1 volt. So closer to being correct. Again, it's supposed to be a 20 volt Zener. So I'm really thinking about just putting that module back in place and then trying the amplifier and see exactly what happens, and then we'll get back to replacing these components if the module is working correctly, and if it's not, I can always take it back out again. So I think that'll be the next step, is to get that reinstalled. All right, so check this out. I reinstalled that module on the left channel. I haven't done anything else to the clipping protection circuit, so none of the components have been reinstalled. I need to order in the transistors and the Zener diodes, so we'll get to that later on. I have the oscilloscope connected to the left channel's output at the speaker terminals, and the amplifier is turned on, and it's been running now for a little over half an hour. And guess what? It hasn't gone into the protection mode, and the left channel's output is absolutely silent. There's no noise pulses or voltage spikes or anything going on. So it looks like the problem was related to those defective transistors, that defective Zener diode. I'm also noticing that the amplifier is just sitting here idling at about 48 watts, which is much improved from the power consumption before. It was 50, 60, even as high as 70 watts at times. So it's really looking good, definitely a step in the right direction. Now keep in mind, I haven't put any audio signals through this yet, so who knows if it has any other issues going on, but definitely it looks like we've got this major initial problem taken care of. So let me move you up to the oscilloscope, and you can see what it looks like as it just sits here and idles on the left channel. I also checked the right channel's output, and it looks perfectly fine as well. So pardon the camera movement here. Just get this moved over here. All right, so that's the left channel. You can see it's set to 20 millivolts per division, and you can see the DC offset is hovering around -5 to maybe -6 millivolts DC. So no issues at all with that. That looks very good. It's just absolutely noise-free and very stable. So again, very happy with the results so far. So let me move you back down to the main circuit board. There's something else that I wanted to point out. So again, pardon the camera movement here. So I'm going to go ahead and shut the unit off just for safety. Turn that off. So I'll go ahead and just disconnect the probe here as well. Don't need that. So if you take a look right down in here, there's a little resistor. So there's an inductor, a coil right there, and then a resistor, and then a second resistor next to it. So the resistor that's on the right side there, to me that looks like a half-watt resistor. The resistor next to it looks like a 1-watt resistor. Now on the schematic, both of these are supposed to be 1-watt resistors, but there's definitely a size difference, and I don't know if it's really apparent on the camera, but definitely when you look at them, there is clearly a size difference. And to me, again, it looks like this one is a half-watt. So I'm going to replace that resistor with a 1-watt resistor, at least if I replace it with a 1-watt resistor and it physically is that same size. Resistors, particularly modern resistors, can vary in size and are more compact than older resistors. Now, this is not exactly an old amplifier, but nonetheless, I'll at least know that it's the correct wattage rating. But I just don't like the fact that it's physically smaller than the resistor next to it. And also, the same group of resistors are over here, and all of these are exactly the same size. So again, it's suspicious that this one is smaller because there's a comparison over here for the size. And the same thing is going on. I don't know if I can get it on the camera. Take a look all the way down here. Let's see here. It is hiding right here. No, you can't really see it. Let me try and tip this up a little bit here. There we go. So the same thing is going on right here with this resistor. So the resistor that's on the right-hand side is physically smaller. To me, it looks like a half-watt resistor, and the resistor next to it is a 1-watt. And again, on the schematic, this is called out as an 82-ohm 1-watt resistor, and I don't like the fact that it's physically smaller. And again, the same thing, if we look here on the board, make sure this is touched up on the focus there, the same group of resistors occurs up here on the left channel, and they're all exactly the same size, and they look like 1-watt resistors to me. So having this one down here that's kind of the oddball, don't like that, so I'm going to replace that one as well. And then right here in the power supply, let's see, I think you can see it. Yeah. So right here, there's these two diodes, there's Zener diodes, and then there's a resistor right there next to it. This resistor is called out as a half-watt resistor on the schematic, and it's physically the same smaller size as some of these others, so it makes sense. I don't have any issues with that, but again, just kind of going by the size comparison and then looking at these others, maybe they were replaced at some point. I'm not really sure why they would be the wrong wattage, but I'll get that taken care of as well. I'm also wondering if maybe some of these capacitors should be changed in here. Some of these are by some heat-producing components, and maybe it would be a good idea to replace those as well. That's an easy thing to do, so I'll kind of look into all of that. Let me get you zoom back out just a little bit here. So I need to get some components ordered in, so I'll get started with all of that. And this concludes this part 1 video. So there'll definitely be a part 2 video when I have the components to continue on with the repair. And then we need to test the amplifier because I haven't put any audio signals through it. So again, I don't know, if it has any other issues going on, so just one step at a time here, but definitely need to do a full power test on it. We need to set the bias, or at least check the bias voltage. There's another circuit over here. I need to take a closer look at that. There's 2 test points and there's an adjustment, and the voltage is not correct on those test points. So we'll take a closer look at the schematic and what's going on with that circuit. I don't think there's a problem. It may just be an adjustment issue, but again, maybe there is an electrical problem. That's a whole other separate issue. So that will be in the part 2 video as well. So stay tuned for the part 2 video, and we'll wrap up this project and again do the testing. I'll go through step by step on checking the bias voltages. The main heatsink is not running excessively hot over here, so I think the bias is probably pretty close, but it definitely needs to be checked. There's some test points across here for doing so. So I hope you enjoyed this part 1 video and the troubleshooting that I've done so far. And if you did enjoy this video, please remember to give it a thumbs up. And if you're enjoying the videos on this channel in general, please remember to subscribe. There'll be many more videos coming up in the near future, especially the part 2 video of this power amplifier. So as always, thank you for watching, and until next time, take care and goodbye for now.